So in Precalculus 30 here, as we embark on Chapter 10, we're talking about something called function operations. So regular algebraic operations are like adding and subtracting, multiplying, and dividing, right? So we just got finished studying Chapter 9, which talked about rational functions. So it's kind of like a x plus 1 on top and a 2x minus 5 on the bottom. That's like dividing, right? So we've already talked about rationals, which are a result of dividing functions. So function operations, we're going to study just that. We're going to add, subtract, multiply, and divide functions. We're also going to put functions inside of other functions, which is really cool and really, really important for us to understand. So that's called composite functions, okay? When a certain function goes inside of another function. And we'll talk more about that, like I say, as things progress through the chapter. So in science, we see a lot of addition and subtraction of functions. What do I mean by that? Well, how many of you have been in a wave pool before? Been in a wave pool? Okay? So when you have two waves coming together in a wave pool, and if you happen to be right at the spot where those two waves meet, and some of you have been through science already, you've been through physics, and you know the principle of wave superposition. When two waves meet, they add to each other and they form a wave that is greater than the two of them. It's actually the sum of the two waves. That's the one wave that's created. When you have, let's say you have a wave with a positive amplitude or a pulse like this, and a pulse, I don't know if I can do this, but it's opposite like this, right? When they meet, they totally cancel each other out. If they have the same amplitude but opposite. So you guys have, okay, science, right? Have you guys been through this in your physics? Okay, awesome. So we can now do this algebraically as well. And of course, this is that's a sonic boom. That's an aircraft breaking the sound barrier. And you guys have been through that too, right? You studied sonic booms in Physical Science 20. Okay, that's probably the most fun part of that little context there. Is when the sound waves actually start to build up and pile up, and when the object goes faster than the speed of sound, those sound waves start to add up and pile up, and there's this small space of really large compression, and when the object goes through that, it busts through that, there's something called a sonic boom. It's like an explosion of all these waves piling up, and boom, they kind of break through each other. But I mean, that's a science lesson. But anyways, so that's basically all these waves kind of adding up. Doppler effect and all that sort of stuff. Sum of waves and that. Okay. So moving on. Another physics application here, right? Two waves when they make waves, there's constructive and destructive interference. So let's get to our first example here. You've written this down already, and you've sketched that graph, okay, roughly. So this is what we're going to do. We talked about adding functions, okay? If f of x was added to g of x, what would we get? Well, let's take a look at f of x and g of x here. First of all, let's try and identify the equation. These are all straight lines, so it should be pretty easy, right? If you look at f of x here, okay, that's the blue one here. F of x is the blue one. So we have a straight line, so we have some linear function. What's the slope of this line? You also have this in your textbook too, this graph, if you want to look closer, page 474. What's the slope of this line? Okay, you go up 1 over 1, there's a point. Up 1 over 1, there's a point. So it's got a positive 1 slope. So we're going to just write kind of 1x, positive x, whatever, just x. Now, how do I finish off this equation? Well, I look at the y-intercept, don't I? The y-intercept is negative 1. So the blue f of x function is x minus 1. Everyone see that? Okay. What about g of x? Now, g of x is actually red, so I'm going to rewrite it in red here to keep consistent with the graph. What about g of x? So g of x obviously has a negative slope, so it's going to be a negative something x. Is it a negative 1x, or what is the slope? So you want to pick a point that you know is on there and count. Go 1, and do we go over 1? Nope. Go 1, 2 down. Do we go over 1? Yes. So the slope is negative 2 over 1, or negative 2x. And of course the last part, y equals mx plus b. b is our y-intercept, so this is positive 3. Okay, everyone see that? Okay. Now, I'm going to leave h of x here for a second. What I want to do is I want to take a look at a couple of the points that would be on f of x and g of x. So what I'm going to do is I'm going to put, I'm just going to I'm going to move these things together here a little bit. And I'm going to make room, and you can do this on your notebook as well. It doesn't matter how you do it. But I'm going to put x kind of here. And I'm going to make 3 little columns. And we'll finish h of x in a second. But these are going to be x values here, okay? So I might put x up there with the other ones. X values. Okay, so if x equals, let's say x equals -2. All right? So f of x, what is the y value, or the value of the function, when x equals -2? You could do it algebraically, or you could look on the graph. Algebraically, you'd simply put in -2 here, and we'd have x equals negative what? 3. -3. On the graph, you go over to x equals -2, and you find the f of x graph, which it's down here. What is the y value? -3. Okay? So this is like stuff you've done years ago in math. Okay, so this is a bit of a refresher here. What about the g of x here? What about g of x? So for -2, where's g of x? Oh, it's way up here. What is that? That is 7. Okay? Again, -2 times... is that right? So -2 times -2 is +4, plus 3 is +7. Okay? Let's just do a couple more. Let's do 0 here. So 0 and -1 for f of x, 0 and 3 for g of x. Let's do 3. Okay. So x equals 3. We have 2 for f of x, and we have -3 for g of x. Okay, so before we get the function here of h of x, before we get the function, let's just find out what these column values are for h of x. So -2, I'm going to change my colors here. -2, where's h of x? Right here. See that? And that value is 4. Okay. 0, h of x is 2. And 3, h of x is -1. All right? Okay, so let's go back and let's now write our equation for h of x. Okay, and you may be seeing a pattern here, right? So what's the equation for h of x? It is this. Well, it's a negative slope. What's the slope? Down 1 over 1. Down 1 over 1. Down 1 over 1. So it's negative x. Sorry? Plus 2. Very good. Plus 2 because of this y-intercept. Okay. So, again, this is the bulk of the lesson right here. Okay? Notice, I want you to notice something. -3 plus 7 equals 4. -1 plus 3 equals 2. 2 plus a -3 equals a -1. So guess what? I've got it written over here. Okay? F of x plus g of x, and this is an alternate notation, which we will talk more about, but that's the same as saying f of x plus g of x equals h of x. Let's confirm this with the equations of the graphs now. Okay, so all right, so we've got h of x. Now let's take a look at, I'm just going to make a little bit more space here. Okay, we've got h of x. Now what is actually f of x? Well, it's going to be x plus 1. See that? That's what f of x is. What is g of x? -2x plus 3. Sorry? I x minus 1. Wow, you are correct. Why did I put x plus 1 there? Thank you. Is that great? X minus 1. Good. So if we add these up, if we add these functions up, we can gather like terms. It's x minus 2x is -x, and then the -1 plus 3 is plus 2. So f of x plus g of x equals h of x. Algebraically, the expression for f of x plus the expression for g of x, look at this, should equal the expression for, right here, h of x. So this plus this equals that. Okay? Can I scroll down a little? Yes. Okay, so this is what h of x equals. So everything's lining up. So here's some notes here on this. When you have two functions, the sum of the functions is the same as adding the y values for each function together. So if you think about the y values, that's like f of x. That's function notation for the y value of the functions, the expression for the y value. Or on a table of values there, the x term, sorry, the y term of one function plus the y term of the other function should add up to the third function, which would be the sum of those two. That always will work. Okay. All right. So before you start copying these two down here. Okay, so we're gonna test really quickly the difference between functions, and just to see if that lines up too. Because addition, we know that we could just add the y values to get the sum function, and let's see if the difference works. So what we're going to test is we're going to test this right here, whether this is actually equal, and we're going to use these two graphs right here. So take a moment just to kind of do a rough sketch here of f of x and g of x. And then we will test some things here. Okay, so we're going to take these two functions and we're going to do a difference now. So we're not going to do a table of values, but what I'm going to do instead is I'm going to take just a number of x values and we're going to plot the difference. Okay, so the difference value. So for example, let's take x equals -4. And for f of x is the blue one, so let's start with this y value, which is -3. Okay, -3. The g of x value is +1. So what I'm going to do is I'm going to do f of x minus g of x, or I'm going to do, more specifically, f of -4 minus g of -4. So what's -3 minus 1? -3 minus 1 is -4. So guess what? I'm going to put a point right there. Okay? All right, let's go to -2 here now. All right, -2. So each function is -1. So what's -1 minus -1? -1 minus -1, that's the same as -1 plus 1. That's 0. Right? Okay, let's do x equals 0 now. So let's do f of x is 1. And g of x is -3. So let's do now 1 minus -3. What's 1 minus -3? That is 4. Okay, so we've got 3 points here. And check it out. It appears that these are in line with each other. It appears that we have a bit of a function here. And a bit of a linear function. So let's just see if that is true. So from this point here, I go up 1, 2, 3, 4, and over 1, 2. Well, that looks like we have, and let's call this h of x, it looks like we have a slope of 2, doesn't it? Up 4 over 2, so 2x. And then it looks like, let's see if that holds true, 1, 2, 3, 4, 1, 2. Yes, it does. And so our y-intercept is +4. So it appears that our h of x function is going to be 2x plus 4. So let's figure out now, then, what f of x actually equals. So f of x, what is that one? Okay, so we've got a slope of 1 and an intercept of 1. It's going to be x plus 1. G of x is what? We've got a slope of -1 and a y-intercept of -3. Does this look okay? The functions? All right. So what happens if we subtract then? Remember, we're doing f of x minus g of x, so we're going to see if this equals actually, h of x. So let's do h of x. Let's see if this equals x plus 1 minus minus 3. Ahead of myself. That is x plus 1 plus x minus 3, which is 2x. 1 minus 3 is minus, oh, sorry, this should be a plus. 1 plus 3 is plus 4. So is this like the sum of f of x? Does that line up with the graph that we identified from the points? And the answer is yes. Okay, so it's a plus x and a plus 3 there. All right, so we've got sum, we've got difference. Okay, that's kind of the big thing here. Let's go to now the summary for the lesson. So turn to page 43 with me. There's a couple extra things we need to talk about before we're done this lesson totally, but let's go from now the summary key idea notes here. So we can add two functions together. We know that the combined function will be the sum of the two kind of function expressions. You add those, combine all the like terms and stuff, that will be the sum. Please note this notation right here. F plus g brackets x. Okay, so that's notation for f of x plus g of x. You can also subtract the two functions and this in the same way. Now let's talk about the domain real quick. The domain of the combined function, okay, by the sum or difference of two functions, is the domain that is common to the individual functions. So this is important. We had no restrictions on the domains of the functions that we studied so far in these examples. But if you had any restrictions on any of the functions that you're adding or subtracting, the resultant function will only have a domain that is common to both. Okay? So I want to highlight that, and I think you should jot that down in your notes because we haven't really done that yet. All right? And here's a bit of an example as well. And this really is the last new thing that I want to introduce to you here. So here's the note here. That's the last little note here, but I'm going to clip this from the summary of the section as well. So the domain of the combined function formed by the sum or difference is the domain that is common to the individual functions. So for example, if this was the domain of f of x, x equals, and I'm going to put it on a number line here for you, x is less than or equal to 3, so it's like here and back, see that? So that's f of x. Let's say that g of x was greater than or equal to -5. So we've got this solid dot here and going towards the right. Then the domain of h of x, which would be the result of the sum or the difference, would only be able to be the domain that is common to both. So everything between -5 and 3. So really where they overlap. Okay? So where both of them are defined, that's important, right? So the domain of the resultant function from adding or subtracting would be the overlap of the domain for each individual one. So the result can only happen where each of the original functions are defined. Okay? So it may take some time to let all of this sink in, but really, we can add, subtract from the graph, adding or subtracting the y values at a given x, or we can add the expressions of the functions. Okay? Any questions? All right. So here's the key ideas, and again, I'll flash up your assignment here for you.